Hello, for this lesson we are working with multiplication properties of exponents. For this there are some rules we want to remember. When we are working with powers, if there are bases that are the same, there's some simple rules that help us combine those. So we don't want to multiply them out and then combine them afterwards. We're looking at how can we work with these powers that have similar bases to make the problem easier, quickly. So the rule that we want to remember is a to the m power times a to the n power equals a to the m plus n power. So what that's saying is when we have the same base, we can just simply combine the exponents using addition, and that would simplify it. You could write it all out in order to find that, but you don't need to. All you have to do is say, well, if it's a to a certain number times a to another number, add those two numbers together. Okay? So for this example, we can see 3 to the third power times 3 to the fourth power equals 3 to the 3 plus 4. Well, that's 3 to the seventh power. And it works just the same with variables. So it would be x to the second power times x to the third power. That will equal x to the second but plus 3. So it's going to be x to the fifth power. So let's look at some of these examples. And we can even write it out all the way in order to see how this actually works. So for number 1, we see this is 3 to the fourth power times 3 to the fifth power. Well, if we remember that that's really like saying 3 times 3 times 3 times 3, okay, multiplied by 3 times 3 times 3 times 3 times 3, okay. So that is going to be, well, how many 3's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 3's. So that means it is 3 to the 9th power. Well, let's see if we agree based on the rules that we talked about at the beginning. If it's 3, they have the same base. So their base is 3. It would simply be 4 plus 5. Well, 4 plus 5 is 9, so bingo. We got it. That was the saddest bingo ever. Okay, so number 2, let's use this, but we're going to look and we notice that we have different bases. We do not actually end up with all the same bases. So one thing you can remember is the commutative property of multiplication, which says that we can rearrange this order. So if I want to rearrange it so that it makes more sense to me, I can do that. I've rearranged this problem. So now it says 4 to the negative 6th power times 4 to the third power times 2 to the fourth. So it kind of moved that to the 2 to the fourth power out of the way so we could take care of our base of 4. Well, if our rule states that it's going to be 4 and 4, those are our bases that are in common, well, it's going to be negative 6 plus 3. Well, negative 6 plus 3 is negative 3. So I'm going to get 4 to the negative third power times by 2 to the fourth power. Okay? Now, when we're working with negative exponents, usually, unless it says otherwise, they will expect you to put it in a form that does not have negative exponents. And what we learn about negative exponents is that it's like saying 4 to the negative third is like saying 1 over 4 to the positive third. So what we can do is we can move that 4 to the negative third, we can move it to the denominator and change it to a positive exponent. So I'll move that 4 to the third power into my denominator, and what that will do is, well, 2 to the fourth, that's positive, so that will remain in my numerator, giving me the answer 2 to the fourth power over 4 to the third. Now, your teacher may expect you to simplify this further. It may say, hey, you know how to do 2 to the fourth power, or you know how to do 4 to the third power. You'll need to follow the instructions in your particular assignment in order to complete it as your teacher or the textbook is asking. Moving on to number 3, that gives us another type of problem where we are starting to see coefficients come in, right? That coefficient is that numerical value in front of a variable, right? So it's 7 times x to the fifth power, or we have 8 times x And that x, that would just be to the first power, right? It's x to the first power. So remember that. So again, we could use the commutative property if we wanted to rearrange it so that everything we wanted was next to it. And so we could rearrange it, and then we could say 7 times 8 times x to the 5th power times x, right? And remember, x, it means to the first power. So, well, here would be 56. And then here we'd say, well, it's x to the 5th power times x. Well, those have similar bases, so it would be 5 plus 1. So it would be x to the 6th power. A lot of times what textbooks will expect is that if we have these numbers here, like 7 times 8, we usually multiply those. Whereas when we usually have 2 to the 4th power, it's usually leaving those with the exponents. But again, check the instructions or ask your teacher what they expect you to do. For this next problem, we see negative exponents, we see a negative number, so let's look at what that means. So we could again use the commutative property if we'd like, or we could start to say, okay, I understand what we're doing. I could write out the commutative property if I wanted to, but I could just say, well, it's negative 2 and 3.5. Negative 2 times 3.5 is 7. And it will be positive or negative. Well, it was a negative times a positive, so that is negative 7. From there I say, well, m to the 3rd and m to the negative 3rd. Well, 3 plus negative 3, that's going to end up being 0. So m to the 0th power. But that's not as simple as we can get it, because if we know our rules with exponents, anything to the 0th power is considered to be the number 1. So what that's going to be is really negative 7 times by 1, which will simply equal negative 7. And that's our answer for that problem. Now this one over here, number 5, this is a big old problem. We have lots of different things, lots to keep track of. So let's use the commutative property, get it back in order. So I'm going to get all of my coefficients in order. I will also notice that there's this negative sign out here, and I always want to keep track of negative signs. Okay? Well, this value is the only one that's negative. So I'm just going to leave that negative there. I know that this number is going to be negative at the end of the day. Okay? So let's rearrange. Let's use all of my coefficients. So I'm going to get 4 times by 12 times by 5. Okay? And then let's get all of my bases together. So I have m to the 2nd power. I have just m. Let's get my r's. R to the 3rd power. And then r to the negative 4th. So this will allow me now, I can see it much more clearly. I've rearranged using the commutative property because it's just a string of multiplication problems. So let's go. All right, I have 4 times 12. Well, that's going to be 48. 48 times 5, that's going to be 240. I know that it's negative. I don't lose track of my negative sign. Over here I say, well, m is to the 2nd power times m to the 1st power. Well, 2 plus 1 is 3. Over here I have r to the 3rd power times r to the negative 4th power. Well, 3 plus negative 1, or I apologize, 3 plus negative 4 is negative 1. So I write that in. Again, we need to make sure, as I described in number 2, that we usually eliminate negative exponents when we're simplifying. So in order to do that, we're saying r to the negative 1st is like saying 1 over r. So I'm going to move r to my denominator. It'll become just positive 1, so I don't need to write a 1. I have 240, and I have m to the 3rd. One thing I need to remember, don't lose track of my negative sign. And that negative sign, I'll put it in front. But remember, with negative numbers, a negative divided by a positive or a positive divided by a negative are all negative numbers. So that could actually have been written, I could put that negative sign in the numerator, right? Those mean the same thing. Or even, if I put it in the denominator, those are all actually the same values. So, but you never want to lose track of that negative sign. Okay? And for the last problem, we're seeing using scientific notation. And we could turn these into standard notation and find the answer to that, but that is going to take a while. So what are the rules that we could utilize from this lesson to make this easier? And again, just use the commutative property, is moving around what order you're doing things in, and that's going to help you to accomplish your goal quicker. So I could rearrange, and I could say, well, 8 times by 7 times by 10 to the negative 5th times by 10 to the negative 3rd. What that's going to allow me to do is say, well, 8 times 7 is 56. 10 to the negative 5th times 10 to the negative 3rd. Well, negative 5 plus negative 3 is 10 to the negative 8th, right? Because negative 5 plus negative 3 is negative 8. So there we have it. Except they will probably expect you to keep that in scientific notation. And if you remember scientific notation, this number out in front, it needs to be between the numbers 1 and 10. It could equal 1, it could not equal 10. But this is clearly 56 is above 10. So it is not in scientific notation. So what we need to do is we need to move this decimal one place further. Okay? And remember, well, 5.6, that's like saying, if I move it one to the left, that's like saying 5.6 times 10 to the first. Right? Because if I multiply 5.6 by 10, that's going to get me to 56. But we already had times 10 to the negative 8th power. And what we need to do with that then as well, we just need to combine that. What that's going to be is 1 plus negative 8, which is negative 7. So it'll be 5.6 times 10 to the negative 7th power. And that would be our solution. It's in scientific notation. So those are some problems that you will see when you're working with multiplication properties of exponents.